Okay, guys, what we're going to do is we're going to change the following logarithms to base 10. Now, you're going to find these quite easy, all right? So anytime you have a log, a basic log, just write down the new base, doesn't matter what it is, and just take the top number and then divide it by the bottom number to whatever base you're going to choose. The base you're going to choose has to be the same. Now, to check your answer, if I was to do like log, 27 base 4, like so, you can see your answer is whatever, 2.38 or 2.377. If I put in log 10 here, base 10, so anyways, log 27 divided by log 4, you'll find out it's the same thing. It's also your 2.37. So all these questions become fairly easy then, because you can just keep using the change your base rule. So if I do this one here, I just write down log 500, I write down log 4 underneath, and then I change it to base 10 is what they want. So that's a 10 there and a 10 there. And then if I want to check my answer, you can always do log 500 base 4, which is 4.48. Okay. Then it's log 500 log 4, which is also 4.48. So you can see these questions actually become reasonably easy after a while. Once again, this is the formal language, but it's all the same, right? You want them all to base E, no hassle. You just put log 20 divided by log 4, and then all you need to do is put a base E underneath. Now, base E is a weird one. There's a word for log base E, it's called ln. So this is ln 20 divided by ln 4. And you'll see this here, ln 20 divided by ln 4. Okay, and you see that the answer is just 2.16. And the answer of the original question, which is log 420, is also 2.16. Now, if you aren't comfortable with ln, you can also do log base E, where you just choose E here. So you just shift E, but you have to do E to the power 1, which is not handy. So if you're ever doing log base E, do ln. So log base E, this part here, it's just best to press the ln button because they mean the same thing. Okay, on 12 part 3, we're going to do log 40 base E, log 6 base E, and you see it's the same thing as log 40 base 6, log 40 base 6, this one here, 2.05. If I do, that's the same as ln 40 over ln 6, because as we said earlier, log base E means ln. And then we just do ln 40, sorry, that should be an a fraction, over ln 6. You see it's the same thing, same answer, right? So that's question 12 done. Same thing with these ones. You get your log and you put your old numbers, the x and the 16, and then you just give them both a base 2. Now log 16 base 2 actually has a value. So if you go to log 16, because we know about numbers, we can check it out. Log 16 base 2 is actually 4. So the answer here is log x base 2 all divided by 4. Okay, if us do question 3, it's the same deal. It's log 3x minus 2 over log 8. Tells me to go for base 2. Log 8 base 2 is actually 3. You can test that out on your calculator if you want. And this is log 3x minus 2 base 2. So, okay. Excuse me. Now, Some of these questions look very difficult, but they're not as bad as you may think. Okay, so here's what we're going to do. Alrighty, so we're going to change the base. Okay, preferably you change the larger base into the smaller base. Okay, that's generally what you do. So I am going to change this one here into log base 2's. So it's going to be log 3x minus 2 divided by log 4. I'm going to put base 2 on both sides. Okay, and I'm just going to write out the other side as is. Okay, now log 4 base 2, if you're wondering, log 4 base 2 is in fact 2. So we get log 2 3x minus 2 all over 2 equals log x minus 1 base 2. Now the 2's are the same, they cancel. It basically means the two of these are the same. And because they have the same log, they're the same base number, this means that this yellow part here has to equal this yellow part here. Just 3x minus 2 equals x minus 1. We're going to get 2x equals minus 1 plus 2, which is 1. And this is x equals a half. Okay, so x equals a half. Now, this question here, it basically says x has to be bigger than minus a half. It's fair enough. You don't even have to pay attention to that part. Just pay attention to the top. Now, pay attention to the top. I'm going to change the bigger base into the smaller base. So I'm going to change that 1 to 5 into log 5. In general, lads, always change the bigger base into the smaller base. The other method is, it works out the same actually, but the other method is slightly more difficult. Okay, bigger base into the smaller base. So it's log. There's our two numbers, which are these two numbers here. Just to change a base formula, let's give them their new base, which is going to be 5's. Okay, and then we still have this log 5 2x plus 1 over here. We have our 16 here. Okay, so log 125 base 5 is actually 3. Okay, so that is actually 3. Now, here's an interesting one. We're going to give them a common denominator. Okay, so you're going to put 3 here, 3 times this divided by 3. And the 3's will just cancel back out if I need them to. I'm going to change this to the 68. I'm going to change 16. I'm going to change to 48 over 3. All the 3's disappear. And what we're going to be left with is 3 log this plus 1 log this. Now, they're actually the same item. It's like 3 tables plus 4 tables. If everybody gets what I'm saying. That's 3 tables. That's 4 tables. So it's going to be, 3 of them plus 1 of them. It's going to be 4 of them. So it's going to be 4 log 5 2x plus 1 equals 48. Now this log here, it's its own number. So you're going to leave this alone for a minute. That's its own number. 4 times this number is 48. So that means we'll divide both sides by 4. This number here must be equal to 12. Oh dear, this is going to be a huge number. This is a terrible question. I'll be interested to check my answer out at the end of this to see if I'm right. It's an absolutely terrible question. We might do 5 to the power 12. What is 5 to the power 12? Good God. Alright lads, so that's 5 to the power 12 right there. I'm going to actually check this answer out to see if I'm correct. There's a reason I don't like this book. Right? So we remember earlier that we can change this into index mode. So it's going to be 2x plus 1 equals 5 to the power 12. Alright? And 5 to the power 12 is this number here. Take away 1 is this number here. So what's it? 244, 244, 140. Like, this type of question will scare you off, maths. Like, you won't even do it anymore. Divide this by 2. And I get 12207. 2207. 0312. Now, see this number here, 0312. Okay, I'm going to check my answer for this. Okay. Now, what I'm going to do with a number like this is I can save it as a letter. So I'm going to press star X. No, that's not how it works. Star alpha X. Give me a second, I'll figure out how to do this again. So, just remembered how to do that again. Okay, let's see if I can find my answer from earlier. There it is there. Okay, so what was it? 122, 122, 122, 07, 0312. Right, here's an interesting way of doing that. You press STO, then press the letter X, and this stores it as X. So anytime I bring up the X button, it represents this number here. So I can go back to my original question, which is this question here, and I can check out my answer. Okay, so I can do log base 5. Log base 5, 2x plus 1. So it's going to be 2, and I'm using the answer I got, 2x plus 1 plus log base 125. And what's it? 2x plus 1 as well. So 2 alpha x plus 1. And it's 16. So the answer I got is actually correct. But I have to say, lads, I've used other textbooks before and I've never had to do numbers as crazy as that. But there you go, I'm actually correct. Happy days. Oh God, these textbooks, I'm telling you. Well, let's pick something that looks reasonable. Okay, I'm going to go for this one here. Now once again, I'm just going to get this colored out. Okay, and let's find out what happens here. So we're going to change the bigger base into the smaller base. So it's going to be log x plus 2 base over log 27. I haven't put in the base yet. The base I'm going to use is 3 because that's the base on the other one. Then you're going to have log 3x plus 2 equals 4. Now, log 27 base 3 is 3. Give everything a common denominator. 3 on the bottom, 3 on top. 12 over 3. 3's cancel. Now, as we said earlier, that's one of them plus 3 of them is going to be 4 of them. 4 times whatever log x plus 2 base 3 is equals 12. You multiply by 4, so you divide 4 into 12. So you go log x plus 2 base 3 equals 3. Now remember the rule for this. The log number is the base number, which is this 3 here, or the red 3. This one can be the green 3, 3 to the power 3, and then x equals 9. So x plus 2 equals 9, x equals 7. If you're not sure about your answer, throw in 7 here. So that'll be 7 plus 2 is 9, 7 plus 2 is 9. And you can check your answer there. What's it? Log 27, 9 base 27 plus log, sorry, one sec. I think this one's wrong. Seems like it just went wrong somewhere. Oh, I totally went wrong. Did I divide both sides by 4? I got 3. 3 over 3 is 9. 9 take away 2 is 7. Alright, let's reserve judgments for the answer. So I'm just putting back in 9 here. Oh, sorry, I'm plugging in x equals 7 to get 9. Just interested in the answer here. The answer didn't check out. The answer wasn't 4, so that means I've made a mistake somewhere. Be interesting to see where. So in cases like this, what you want to do is you want to go right back to the beginning. Okay, I chose 3 as the base. So log x plus 2 base 3, 27 base 3. Now log 27 base 3 is in fact 3. So that's what I would have done earlier. We'll change that to a 3. I would have given them all common denominators, like so. And 3 multiplied by 4 is 12. Cancel the 3's. 1 of them plus 3 of them is 4 of them. 4 log base 3 x plus 2 equals 12. Oh, I see where I went wrong. I went wrong right at the end, which is really frustrating. 12 divided by 4 is 3. So where I actually went wrong was I said I did 3 to the power 3 is 9, but 3 to the power 3 is actually 27. So that's where I foolishly went wrong. So you see your x plus 2 here? You cross multiply it up. That's 3 to the power 3. I previously wrote this down as 9 instead of 27, which is, and then your answer is 25. So once again, if you go back to the top and you put in 25 instead of 27, so that'll be 27 because 25 plus 2. 25 plus 2 is also 27. That'll be 1 plus 3, which equals 4. So it's always worth checking your answers at the end, lads. The answer check really tells you if you're right or wrong, especially in my case. All right, lads, I think we're good with these ones. I think we might skip on to the next question, which is question 15. Okay, and we might try the same stuff here. Okay, I'll just start off with question 1. Can work our way up. Okay, change the bigger base into the smaller base. So it's going to be log 3x plus 1 divided by log 4. New base is going to be 2. Log 4 base 2 is in fact 2. Is that right? Now, we're also going to have log x minus 1 base 2. Now, if I was given as a common denominator, it would be 2 on the bottom, 2 on top, and then the 2's don't matter anymore. Now, unlike previous questions, what we're going to do here is they're not the same number. In question 14, they were all the same number, so that part here would equal this part here, but they don't do that this time. So because they don't do that, I'm going to bring in this square rule. See that 2 at the front? This 2 at the front, I'm going to bring it over here and change it into a square using the multiplication law. Okay, now what I can say is that because both bases are the same, I can now say that this part here is the same as this part here, and that the two blue parts are actually the same as each other. So I can say that 3x plus 1 is the same as x minus 1 squared. Now x minus 1 squared is x minus 1 by x minus 1, which is x squared minus 2x plus 1. That's 3x plus 1. Bring it out the other side, and you're going to get x squared minus 5x. The 1's cancel, that becomes a minus 3x. You're going to get that equals 0. You're going to solve it. X bracket x minus 5 equals 0. You either get x equals 5 or x equals 0. Now, x cannot be 0 for the following reasons. If I put in 0 here, you're asked to get log of a minus number, and a log of a minus number does not exist. Log any minus number you want. It's just never going to happen. This is because in power series, 2 to the power 1 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power minus 1 is a half. These numbers here are never, ever, ever negative. That's why we can never have a negative answer. So x equals 0 is the wrong answer for this question. The only answer is x equals 5. Okay. Now, let's try another one of these. Suppose we go for part 4. Make things interesting. Okay, here's part 4. Now, I'm not allowed to use the addition log rule because the two of these cannot be added because the bases are different. I'm going to change base 3, which is this one here. I'm going to change it into base 2. That's generally the plan. Okay, so it's going to be log x over log 3. And then your new base number is going to be 2. The problem with this is that this base number here is actually not a nice number. Basically, it's like a decimal number, which isn't brilliant, to be honest. Okay, I suppose I could store the answer as a decimal and then try and get my answer in decimal form, I suppose. Because you go log 3 base 2 isn't a great number. Once again, very new to this book. I haven't done it any other way. So I think I'll round off that 49 to 585. So that'll be 1.585 for me. I could also have it stored as like that 1.585 is meant to be log 3. Sorry, what's it? 2 log 3 base 2. I'll just keep it like that for a second. Do you know what? I'll store it as a letter. I just think something's going to go weird at the end. I'm going to store it as a letter A. Just give me a second. I'm just going to store it as the letter A. And don't mind what I'm doing with it for the time being. So I'm going to store that number as letter A. So common denominator will be A on the bottom, A on top, A on the bottom, A on top. Now, what's going to happen here is the A's disappear, like so. And we have two of these together. Okay, so the two of these are, it's A plus 1. If A was 3, it'd be 3 plus 1 is 4, but it's not. But I can factorize out log 2 base x, and that is A plus 1. Sorry. Ooh, sorry. That's very, very mixed up here. See the A plus 1? It's A plus 1 multiplied by log x base 2. Because they're the same number as each other. Okay? And that equals 1a. To get the x on its own, we're going to go log x base 2 equals a divided by a plus 1. Now we all know that a is log 3 base 2. Okay? Now, x on its own, remember earlier, if I asked you for 8 to the power of 2 equals 3, to get the 8 on its own, 8 equals 2 to the power of 3. This is the same thing. To get the x on its own, it's x to the power of 2, a, and another a plus 1. Now, and a equals, what did we say a was again? Log 3 base 2. So I'm just going to put all this in the calculator. Okay, like so. It's going to be 2 to the power of, I need a fraction. Anywhere I see an a, it's log 3 base 2. So log 3 base 2. And then underneath, log 3 base 2 plus 1. And your answer is a decimal anyway, so no real point. 1.53. Fair enough. Now, if I wasn't so sure about this answer, I'd go back to the start. And anywhere I see x, I'll just put in roughly 1.53. Or press my answer from the last question. That there is 1.53. Put your answer in here again. Yep, that answer is perfect. 1.53 is absolutely perfect. Insane question, lads. But just ludicrous, if I'm being honest. Like, just simply stupid. Alright, these questions here, I don't think I have much, oh god, much more of these to do. I'll do question 2. And maybe I'll do 2 and 5 maybe. So these are similar to what you got in the revision sheet. Y equals 3 to the power of x. So y squared equals 3 to the power of 2x when you square both sides. For those of you missing that part, it's 3 to the power of x to be squared. So y squared equals 24 minus 5y. Y squared plus 5y, take away the 24, equals 0. Y plus a and y minus 3 equals 0. Y equals minus 8. Y equals 3. Now here's the hard part. 3 to the power of x equals minus 8. And 3 to the power of x equals 3. So x equals 1. There's no power of 3 that will result in minus 8. 3 to the power of 1 is 3, 3 to the power of 2 is 9. There's no negative numbers in that list, so that one's a wrong answer. There's only one answer. X equals 1. Okay, x equals 1. That's the only answer you need for that. If you aren't sure about the answer, plug it back in. That'll be 3 to the power of 2 times 1, which is 3 squared, 24. 3 to the power of 1 is 3, that'll be 15. 9 equals 24 minus 15. 9 equals 9. You know you have the correct answer, okay? So, if I'm being honest, this one here looks to be one of the tougher questions here. Question 4, actually. So, with question 4, I know it's squared on both sides. I'm just going to square in that number, and it's the multiplication rule. Remember I said 3 to the power of 4 to the power of 2 would be 3 to the power of 8. So I'm just going to multiply in by that 2, and I'm going to get 3 to the power of 2x plus 2 equals 100. Now, there is a rule for this. Okay, it's a tricky rule. Is I'm going to log both sides. Okay, if I told you that 5 equals 5, then log 5 equals log 5. Or if I told you that 6 equals 4 plus 2, then log 6 will be the same as log brackets 4 plus 2. So I'm going to use a similar system here. We're going to say log 7 to the power of 2x plus 2 is the same as log 100. Then what I'm going to do is I'm going to use the power rule to bring the 2x plus 2 to the front. And that's log 7. That's log 100. And then I'm going to bring down the log 7 because it's being multiplied by the 2x plus 2. So 2x plus 2 equals log 100 over log 7. And it says in the question description, 2 decimal places for the answers, okay? So that's happy days. So I'm going to do log 100 divided by log 7. .3666, let's call it. 2.3666. More decimals than I need. Bring it over to 2, take it away, and then divide by 2. So take away 2, and you get 0.3666. Divide that by 2. Divided by 2. 0.1833. Now, if you aren't so sure about your answer, throw it back into the original equation. You're going to get 7 to the power of 2 times, what's it, 0.1833 plus 1. Oh, sorry, I'm doing the 2x plus 2 version here. So I do it into the original one, which is this one here. So I need to actually enter it into brackets. So it's going to be 7 to the power of 0.1833 plus 1. Close your brackets and square it. Now, because this is rounded off, it won't be exactly 100, but it'll be pretty damn close, right? So that's how you know you're right. Happy days. So I did 2 of them now. Happy enough with doing 2 parts of 16. Now, straight to 18 apparently.